Hello friends, so today we are solving this problem. Find subsequence of length k with the largest sum. So we are given a array nums and an integer k. Okay, and we want to find the subsequence of nums of length k that has largest sum. Okay, so for example, this is our num. Okay, and this num has basically these are the numbers inside it. Okay, now k is given equal to 3. Now we have to find a subsequence that makes the largest sum. For example, there are multiple 3 length subsequence. For example, 5, 9, 10. This is also one subsequence. 3, 9, 10. This is also 3 length subsequence. There could be multiple. But you can see here 13, then 9, then 10. This is also a 3 length subsequence which makes the largest sum, 32. 13 plus 9 plus 10 equal to 32. So then we have to print, our answer should be 13, 9, 10. That should be our answer. 13, 9 and 10. We have to find this subsequence in the same order. Okay, so what we can do is we can go in a priority queue way. Okay, so how would you do is, you can observe one thing here, that whatever would be the answer is basically the top elements, biggest elements of size k out of this, right? So you can see here top 3 elements. Who are the top 3 elements? 13 and 9 and 10. These are the top 3 elements out of this array. So basically we have to find top k size elements. Okay, and out of that we also need to know about their ordering. So this is what we have to do. So for example, if let's say we want to make a priority queue or min heap, you can call in general, if I create a min heap and keep the size equal to k. Okay, so in this min heap, if I keep on adding the values and whenever it is going beyond the size k, then we can pop those values. So in that way we can solve the problem. But remember, we have to also take care of their locations, their sequence should be same the way in which they are ordering. What we're gonna do here is we will create a class called item. Okay, this item class is basically having the two values, value and the index. Means like whatever is the index of those values, like in this case 0, 1, 2, 3, 4, 5, like this. Okay, so similarly we have to store their index as well, not only the values. Then only we will be able to find the indexing as well. Okay, so what we are doing is, this class would be having value and index, two variables. So we are making a priority queue, min heap. So we will keep on we will keep on adding the values into this priority queue first. Okay, so it is like, let's say it will come, first of all it is -2, which is sitting at index 0, right? Then it would be 13. Okay, so 13 we would be adding here. And then we have like it will go like the smallest value. So this priority queue, this one is the based upon values and this one would be based upon the indexing. So let's talk first the values one, because our first criteria is to get the k size top k values, right? So first of all we will start from here. So it would be -2 at 0. So it would be something like here, -2 and at the index 0. So this is the item class object. Then we have 13. So let's say 13 also we are adding. So 13 is sitting at index 1. Similarly, we are at 3. So at 3 is index, 3 index is at 2, right? So now its size is 3. Now we will add this 5. So 5 is sitting at index 3. 5 is sitting at index 3. But wait a minute. Now the size is become 4. So we have to remove the smallest element because we are interested to find the top k. Okay, so we have removed this guy. We have to keep the size equal to k always for this guy, for this priority queue. Okay, now we are coming at 9. So once we add the 9, one of them would be deleted. So which one is the smallest? 3 is the smallest, right? So we will remove this guy and we will add this guy, 9. So right, so 9 is sitting at index 4. So we will keep it adding like this, 9 sitting at index 4. Now we are coming to this guy 1. So 1 is sitting at index 5, but it will go to the, once we will add it here, the size would become greater than the this guy, greater than k. Then what we will do is we will remove top element. So top is right now this guy only, this we will remove. Okay, now we are coming to the final one. This is 10, which is sitting at index 6. So we have to remove top elements, right? So 5 would be removed from here and 10 would be added. 10 is sitting at index 6, so 10 and 6 like this it would be added. So now you can observe here that we have found the top k elements with their indexes. So we just cannot put it like this, that 9 and 10 and 13. We cannot put it like this because they are not appearing in this order. You can check here, 13 occurred very first time, then 9 came at second position if we take this, and 10 came last, but this is not the correct ordering. That is why we are keeping track of the index. Now what we will do is, from this PQ we will put these values into the priority queue 1. This priority queue 1 is based upon the indexing. This was based upon the value. That is why value is on top. Now what will happen? This min heap PQ1 would be, we will put all these values. All these 3 values we transfer to this PQ1. How it would be tagged? It would be tagged based upon whoever the smallest index. So 1 is the smallest index. So 13 would be coming here. 13 and 1. Who would be the next value? Next value would be this guy, 9, 4, because 4 is the second smallest. So this will come like this, 9 and 4, right? And final one would be this one, 10 and 6. So 10 and 6. You can observe here all the indexing is coming in the sequence. First we came with 1, then we came 4, and then we came 6. Now what we will do is we will pop out these values into an array. We can create an array of size k. So 13 would be very first. We will pop this guy. So 13 value. So we will put the value 13 here. The next guy would be this guy, 9, 4, right? So 9 would be coming the second value. Now final would be the 10. So we will pop out this 10 here. So 13, 9 and 10. Now you can see they are appearing, they are the largest one, which is making the sum equal to 32, and also their sequence you can check here. See, 13 came first, then second one came 9, which is appearing here, and then finally it is 10. So let me show you my corresponding code. So see here, I have created this item class having value and index. Now I have created the 2 priority queue, PQ, which is based upon the value, and this PQ1 is based upon the index, right? These priority queue are accommodating this class object item. Now what I am doing, first of all we are traversing through this nums array, and we are adding these values, right? We are creating the item object and adding this to the priority queue 1. This is our this priority queue PQ, this one, right? So once we are added one, see what we are doing is, whenever the size is going beyond k, we are popping out those elements because we want to keep the size equal to k. Once we are done with this, we are done with this priority queue. Now what we are doing is, we have to move all these values to PQ1 because this PQ1 is based upon the index based bin heap. So once we added all of them, then we are creating the answer variable of size k, and we are popping out everything from PQ1 based upon the indexing, and we are taking the values out of that item. We are taking only the values, right? And we are returning this answer. So let me execute this code. So I am executing it. I have already submitted it, but let me submit it again. So what would be the time complexity here? So time complexity, we are not sorting entire array, but we are just taking the k values in the these min heap, right? So it would be n log k. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.